This optimization problem uses trigonometry and so requires a bit of cosine and sine knowledge. Firstly, we need to deduce that the cross-sectional area of the gutter is such. So what we'll do is we'll divide that gutter into sections. Firstly, the rectangular section, which is going to be in blue, and the other two identical sections, which I highlighted in green. So the total area consists of that rectangle x, y, b, c plus triangle AXB plus another triangle YDC. Okay, we know the length of BC, we also know CD, and we also know AB. They're all the same. But now we need to find out what BX is, and also in the same process YC. They should be the same. Not only that, we also need to find AX, and we'll also need to find YD. And we use sine and cosine rules to find out these lengths. We know that cos theta would be XB, adjacent side, over the hypotenuse side, which is this. And since we want to find what XB is, that's actually 10 times cos theta. And sine theta, which is equal to AX, opposite, over the hypotenuse, will mean that AX is 10 sine theta. And we'll need to use these two lengths to figure out the area. And so the area of the square, which is 10 times XB plus two lots of triangles, which are going to be a half times XB times AX. Okay, we can cross out the 2 and the 2 over here. So we shall end up now saying it's 10 times. What's XB? XB is 10 cos theta. And leave that in the brackets. Plus we've got XB times AX. And XB is 10 cos theta, while AX is 10 sine theta. If we simplify this and multiply the 10 and the 10 together, we'll have 100 cos theta. And we have plus another 100 here. And we have a cos theta. And we also have a sine theta. By taking out 100 cos theta and 100 cos theta from both sides, we have 100 cos theta, and we're with a 1 plus sine theta. And that's exactly what we wanted to get. Up here, that's what we wanted to get, 100 cos theta, 1 plus sine theta. Now we need to show that the derivative of that area, when it is equal to 0, it'll be sine theta is equal to a half or minus 1. This means that we need to do now dA over d theta. This is going to be a product rule of cos theta and 1 plus sine theta. So I'm not going to involve the 100 in here. I will take the 100 out, okay, and I will try and do u dash v plus u v dash, where u is equal to cos theta, and therefore u dash is equal to minus sine theta, and v is going to be 1 plus sine theta, and v dash is going to be cos theta. I'll put this all together, 100, and in here times cos theta. This can be simplified so that it's 100. None of this is really very helpful because we've got a sine theta here, sine theta, and a cos squared theta, and we want to make that whole dA d theta be equal to 0. So what we want to really do is to put it in a kind of a terms where we can get a null term like AB is equal to 0, because then if A is equal to 0 or B is equal to 0, the whole thing becomes 0. That's what we want to do. Now, to consider it further, we want to also maybe change that cos squared theta so that it's all sine theta. Before we do that, let's just multiply all this out here, sine with 1 and sine with this. All right, so we've got sine squared, cos squared. These two remind me that there is an identity law. So I'll want to rearrange this so that I can have something for cos squared theta. So that will mean now that I have this, so I can now substitute cos squared theta, this cos squared theta, in here. Step by step, I'm just trying to show you what is actually happening over here. So I'll have minus sine theta minus sine squared theta plus 1 minus sine squared theta. Okay, now minus sine squared theta and minus sine squared theta can now be added together so that I'm left with minus sine theta minus 2 sine squared theta plus 1. I have a minus sign here and a minus sign here, too many minuses sign. I'm going to take it out. This reminds me of a quadratic. Have a look at this. If I wrote down x2 x squared plus x minus 1. I should be able to factorize that. Remember, I already said that I wanted it to be in the AB form here before. So if I can do that, that would be really, really helpful. So if I was to substitute the x for sine theta, I could rewrite that in terms of 2 sine theta minus 1 sine theta plus 1. Okay, so that's what we'll do. We'll write this down here. It's equal to minus 100, and then we will write 2 sine theta minus 1 sine theta plus 1. And now we have it in the form of A and B. So we can now say that dA over d theta, and we can make that equal to 0, because if 2 sine theta minus 1 is equal to 0, or sine theta plus 1 is equal to 0. This means that sine theta, for it to equal 0, must be equal to a half, and this suggests that sine theta must be equal to minus 1. So we have two options. Sine theta must be a half, or sine theta is equal to minus 1. So the gutter has a maximum capacity when sine is equal to a half, or sine is equal to minus 1. On a unit circle, the coordinates here are 1, 0, and up here they would be 0, 1. Okay, so I've drawn this because I want you to have a look at this. This here would be pi on 2. Okay, I've got 3 angles here that are really very important and you really need to know. The 30-degree angle, the 45-degree angle, and the 60-degree angle. Because we're using radians, it'll be pi on 6, pi on 4, and pi on 3. That's how you need to be used to it. So if you want to remember what their values are, I just want you to write this down. I want you to write 1, 2, 3. Also on the other up the y-axis, you'll write 1, 2, and 3. Because all you need to do is to put a root and divided by 2. A root and divided by 2. A root and divided by 2. Do the same thing on this side. A root and divided by 2. A root and divided by 2. And a root and divide that by 2. And these are the cos values, and these are the sine values. So now all you need to do is put them across. So this coordinate over here will therefore be, and of course root 1 is 1, so we'll just say that's 1 on 2, and the sine will be root 3 on 2. This particular one over here is 45, or pi on 4, is now going to be root 2 on 2 as root 2 on 2. And lastly, pi on 6 is going to be root 3 on 2 and 1 on 2 here. So this is only in this quadrant, but this relates to all the other quadrants, except that you need to take care of the negative signs. So when we're talking about sine theta being a half, the only time that you can get sine theta is a half is here. And that means that theta must be pi on 6. So for this example over here, theta must be pi on 6. Now our gutters can obviously not be more than 90 degrees, which is 3 pi on 2. So the gutter has a maximum carrying capacity only when theta is equal to pi on 6. And when we do the sine test for that, we'll find that that is pi on 6. It cannot be less than 0, and it cannot be greater than pi on 2. So we find that that's positive and that's negative, so we'll find that that is a maxima. All right, to find actually the cross-sectional area, we'll now insert the pi on 6. So to look at the cross-sectional area, we'll go back to our original area and we'll just substitute for theta pi on 6. 1 plus sine pi on 6. And we've already figured out from above that cos pi on 6 is going to be root 3 on 2. So we'll write down times root 3 on 2. And then 1 plus sine pi on 6 is a half, which is 3/4 of 100 times root 3, and that'll give us, which turns out to be about 130 centimeters cubed. So that is our cross-sectional area.